All right, in this video, we're going to look at an application for linear functions and finding the least squares regression line. So when we plot data points, for instance, if we observe values and plot them on a Cartesian plane, we can sometimes create what's known as a least squares regression line that is going to help us describe and predict data values. And most technology, like graphing calculator technology, has the ability to do this. And you're going to notice some things that you may not be too familiar with. First up will be what's known as a correlation coefficient, which will be given by an R value, and that determines how well the data falls into line. So the closer R is to 1 or -1, the better the data falls into line, the better the linear fit, which is really nice when you're trying to make predictions on future values or maybe missing values in between data points. So example 5 here, the census data for Lake County, Ohio is shown. We have, starting in 1970, the population is 197,200, and then just as the census goes every 10 years since then. So we're going to find the least squares regression line for this data. And I'm going to start with 1970 as x equals 0, and then from there, the values of x are going to represent how many years after 1970. So if 1970 is x equals 0, 1980 will be x equals 10, 1990 will be x equals 20, etc. So in Desmos, if you go into the plus sign and click on table, you can create a table just like I did right here. So make sure I'm in OK in projector mode. Now, our linear functions are in like y equals mx plus b form. So here's how you get regression equations on Desmos. So if you click on the little keypad here, type in y and then 1. Notice this little subscript of 1 here. And then you want the tilde symbol, which is this symbol right here. So to get there, press the ABC button, and then it's this symbol right here below the B and the N. And then we'll go M, and then we want X1, and then plus B. So we have X1 list, Y1 list. We have Y1 tilde M times X1 plus B. And our value of R is 0.9666. So if we zoom out and just trying to find the points here, hide the line for a little. If we zoom out, there they are. So there's our data points, and look like they're a vertical line because the slope is pretty high. Here's our least squares regression line. Does a pretty good job at lining up all the data points. They're not all perfectly in line because the distance of y, the difference in y values isn't always the same. But we have R as 0.9666, which indicates a very strong positive correlation. So as our year goes up, our population goes up as well. This value of R squared is called the coefficient of determination. You won't need that for this course, but if you take a course in statistics, you'll study it with regression and all that. So, but here, the values of the slope is 803.92, so about 804, so it explains the very steep line. And our y-intercept, 200,532. So our least squares regression line is y equals 803.92x plus 200,532, where x represents the number of years since 1970 and y represents the population of Lake County, Ohio. So interpret the slope of 803.92. We'll round it up to 804. But because the slope's positive, our function is increasing, and our population is increasing by about 804 people every single year. So in terms of the steepness of this line, this red line here has a slope of about 804, which explains why it's so incredibly steep. So every year, the Lake County, Ohio population is increasing by about 804 people. Predict the population of Lake County in 2070. So in this case, we want to know what the population is going to be in the year 2070. Well, that's 100 years after 1970. So if we plug in x equals 100, we get about 280,924 people. So well on our way to close to 300,000 people in Lake County predicted in 2070. With some that may be of interest to city planners, in what year is the population predicted to exceed 250,000? So if you're in charge of zoning and permits and city planning and all that stuff, it might be very valuable for you to know when your population is going to exceed 250,000, because you might have a lot of scrambling around to do to accommodate that many people living in a county. And not a very large county and area in Ohio, so it'd be important to know to be able to plan ahead. But we want to know where our function is greater than 250,000, and if we subtract 200,532 and divide by 802.92 or 803.92, we get about 61 and a half years. So it's predicted to exceed 250,000 in the year 2031. Now, whether or not it does is dependent on a lot of other factors, but in terms of linear regression and using a linear model to predict the population, we are predicting to exceed 250,000 people around the year 2031. So, all right, that about does it for this video. Thanks for watching, and I'll see you